welcome you at the seventh React Native Community Kraków meetup. After a pretty long break, it's great to see everyone's faces here at our office. I also want to welcome you to our office. And yeah, let's get started. We have two fantastic talks just following after a short introduction. And yeah, so this event is happening after a pretty long break. The meetup number 6 was in January 2020, which means it was like a year and a half almost ago. And yeah, I tend to do that intro showing what's happening in React, and I was kind of covering things since the last meetup. But since it was like a year and a half almost since the meetup number 6, I'm not going to be talking about things that happened. There's been a lot of things happening. So yeah, so just to keep the tradition going, I'll have a short introduction about what's new in React Native. So instead of just talking about that year and a half of full of events, I'll be just covering the past like month and something. But I'll also have references to the last meetup. So the first thing I wanted to mention. So in the last meetup, one of the highlights was the article by Coinbase about their release of the Coinbase Pro app on Android, and they recently also posted a very interesting blog about their successful transition, not only the Pro app but also the main app to React Native. So really encourage you to read that. Very interesting findings and then a lot of great content there. We'll be posting links later, and the talk is also recorded, so the links are going to be on YouTube. Next thing, so on that meetup in January 2020, I was mentioning the release of SDK Expo SDK 36, which among other great things also had a dark mode support. Was the first release to include that, and just recently Expo 42 has been released, and also many interesting features. Among others, there is this preview release of custom development clients. For those of you who used Expo, one of the greatest things is that you can just like install this SDK client on your app and just like start using the whole framework, or like make changes and like see what's happening and get everything set up without actually like installing native apps. So you can just install it from the App Store. And what the custom development clients allows you to do is to actually have a very similar experience, but also allow you to install custom libraries and custom native code. There's also experimental support for Hermes, which was a long-awaited feature. I think so. So really great release, and yeah, there will be new one. I hope very soon. So keep up to date with all the updates just following Expo on Twitter. Yeah, and the last thing I was discussing or talking about on that meetup in January 2020 was the journey to Reanimated 2.0. It was the first time I discussed our plans regarding Reanimated 2.0, and actually throughout the past year we managed to release Reanimated, which is the animation library for React Native, that is developed here in-house by my open source team, or our open source team at Software Mention. So we released that. But another thing I discussed was the new API for transitions, and that hasn't actually been a part of the initial Reanimated release, and just recently has been released. So the thing that I consider the replacement for the transition API was part of Reanimated. Just recently it's been released as a part of Reanimated 2.3 update. There's also a lot of great content that has been created about Reanimated throughout this whole year. So this is just one of the recent examples from William. If you don't know William's channel, you definitely should check it out. So there are many interesting animations built in React Native, and a lot of them use the libraries that we develop here at Software Mention. What next? A recent tweet from Joshua Gross from Facebook announcing that they migrated all of the React Native screens that are part of the Facebook main app to use Fabric renderer. Fabric is the new architecture that they've been working on at Facebook, and also migrating towards incrementally since January 2018. And yeah, so that this marks an important milestone for them, and we hope that their efforts will now focus towards working with bringing this to the open source, so everyone outside of Facebook also will be able to use Fabric hopefully soon. Other things happening. So interesting tweet from Oscar about his Oscar Franco about his library that he released for which is essentially like a wrapper on SQLite, but it uses JSI, which brings some interesting performance gains. So if you are looking for database solutions, it's an interesting proposition, definitely. So check it out. And finally, last thing I wanted to mention is there's article about using React Native app on M1 MacBooks or Macs in general. So that's a thing that a lot of people have been asking about. So a lot of people are migrating now to M1 Macs, and obviously there is some trade-offs and some difficulties with setup. So this article covers a lot of aspects of that migration. So if you're interested about like seeing what's coming, if you are planning on migrating, then check this article. And there are also interesting pointers to like how to solve some of the issues so that you don't need to use Rosetta, which is the x86 emulator mode on M1 Max. So that's it for the news. Yeah, as I mentioned earlier, today we have two talks. So first one is Tomasz, who will talk about using hooks. And then we will have Alec talking about design systems in React Native, and not only, I think. So yeah, give them a round of applause, and yeah, that's it for me.
Okay, so I would like to talk about React hooks, specifically the most common mistakes which are made by developers and what we can do to avoid making them. But before we jump into it, let me introduce myself. So, hello, my name is Tomasz Pałys, and I'm working here in Software Mention as a software engineer. I've been using React for the last 4 years, probably. And from the beginning, I really liked it, but only after the hooks were introduced, I started feeling that this is something really amazing. So, why I've decided to talk about this topic. So the hooks were introduced more than 2 years ago, but still some programmers doesn't use them correctly. There are a lot of mistakes which I think can be easily avoided. I once was asked to review a project where developers were using hooks, but there are some mistakes which they were making constantly, and I heard an opinion that like having everything correct isn't necessary, or maybe even the cost is too much. But currently I'm working in a project where we're using hooks a lot, and we try for them to be as efficient as possible and as correct as they should be. And I can assure you that it's possible, and the cost is, I think, relatively small. So I think it's worth doing it. And yeah, let's spend a moment talking about hooks in general. So what are the advantages of the hooks? In my opinion, reusability is one of the most important things which hooks allow us, especially the reusability of stateful logic. Also, when we're using hooks, it's easier to reason about the state of the component. For example, when we're using a class component, let's think about what we have to do when we would like to fire a function every time component updates. It's not only about component did update, but also component did mount, and then we have to clean after our logic in component will end mount. So instead, we can just use effect, and it handles all that cases without us being aware about those complexities. So I think it's a lot easier. But hooks have some issues. For example, it's relatively easy to use them incorrectly. For example, when we have an effect or memo or something, and we forget about a variable in a dependency array, well, the result might seem correct sometimes, sometimes not. I will talk about it later, how we can avoid it. It's obvious probably, but yeah. And also, they're not always doing what we expect them to do. When we think, for example, about use ref, the obvious thought is that ref is for refs. But there are some other use cases which I will cover today. And also, when sometimes use callback to introduce a memoization of a component, it isn't enough. It's sometimes necessary to use react.memo, for example, which I'm also going to mention later. There are a lot of hooks available, but I'm going to focus mostly on this one because I think they are the most common, and also avoiding mistakes while doing them is comparatively easy. And also because they're used so commonly, mastering them is a really important thing. When using hooks, there are two rules which we have to obey. One of them is about calling hooks only at the top level of the component. It means that we should avoid calling them from if, for example. And also, when we call a hook, we should do this from React functions or from other hooks. When we call them from a simple JavaScript function, then it's not something which is going to work. Well, it might sound that calling hooks from the top level is something so obvious that we don't have to think about it. But when we have a situation where we created our custom hook, and this custom hook only expects a given range of values, for example, or maybe a value to be non-nullable, and then we wrap it into another hook, and these hooks have some difficulties with like creating this value, it is tempting to wrap a hook into an if to avoid an issue. And it's something usually complicated to work around. I've once encountered this problem in my project where I created a hook which expects a value to be present, but this value that didn't make sense in a lot of contexts in which an outer hook was used. So what I've done was to modify my hook to work correctly even if the value was null. But what we can do to detect this error instead of only thinking about avoiding it? Well, a string plugin. I really encourage you to use it. And yeah, it's going to save you a lot of time. So SLint plugin, rules of hooks, that's the way to go. The next part is about dependency arrays. Dependency arrays are used by a couple of hooks, and it's really important to understand how they're working. Yeah, it's important to not forget about any dependency. For example, when we have a memo, we would like it to reevaluate every time each value used inside it is changed. To make sure that it happens, we have to list every dependency in an array. It's even more important when we're talking about effects, because it's obvious to notice that memo wasn't correct, but effects might be more tricky to detect. And also, we don't always need to obey to this rule. For example, when we would like to log a value when the component renders for the first time, we can skip the dependency array. And yet again, SLint rule is the way to detect those issues, and it let us make an informed decision about when to violate this rule, when we really want to violate it, and not only forgot about listing dependency. Dependency arrays are compared shallowly, which means that only references are compared. So, for example, when we have two entities which are the same after every render, but we define them every time, for example, a function, which is lambda here, then this effect will be fired every time, which is something we don't want to happen. We don't need an effect if we want to fire something on every render. So what are the solutions to that issue? Well, the most obvious one is to use callback. We can wrap our function in a callback, and then this callback is stable in terms of the dependency array it has. So use callback guarantees that every time the dependencies change, the reference of the function will change, and if the dependencies are the same, then reference is the same, so we can easily use it as an effect. Another solution is to define our function inside an effect. I know that this example might sound too simple, but sometimes when we define a function, we do this to encapsulate our logic, make it easier to understand. And if we do that, we can probably move function creation to the effect. And the last option is about creating this function outside the component. Well, if this function depends on properties of the component, it's not always possible, but we can even consider passing the props into this function as arguments, and then this function is going to have a stable reference. So it's also worth considering it. Yeah, all the arrays, objects, and functions are different in terms of equality operator. So whenever we're comparing two arrays, even if their value is the same, or when they represent the same value, the references are different. This is really similar to what we were talking about in the previous slide, but this time, let's imagine that a parent component passes an array to its child. Well, this is a big issue because every time a parent renders, it's going to create a new array and pass it to its child. So if the child decides to memorize, for example, using this array, well, it's not going to work because the array will be different on every render. The solution is, as usual, memoizing using callbacks or defining the object outside React function. It's not a big mistake to list an object here as a dependency. Well, we're only using two properties of it, and it will work given that the parent takes care of what's inside this S object. But we can do better. Yeah, as you can see, we're now listing the properties we're using. This might improve our performance because even if other properties of this object changed, we're not going to do recomputation. Something like this might even make our code correct, because when we're using effect and wanted to detect every change in the values, we would like to avoid false positives where some other property of the object changed, but not the one we're interested in. So it's worth having this option in your toolbox when dealing with a hook which uses dependency array. In this next part, I'm going to talk about memoization. So the problem we can see here is that component renders every time the component renders every time the component 2 renders. This happens because we're using a lambda in this function. And one of the options to solve it might be to use callback. But it doesn't change anything. The component will render every time component 2 renders. That happens because we don't know what this component is. If it receives the props in a usual way, then it's going to be rendered every time its parent renders. If we want to avoid this, we can use memoization of the component. So, for example, we can wrap it with react.memo and then export it instead of the component itself. The other options are more about class approach. We can use pure component or should component update. Only a limited number of built-in components are memoized. So I've noticed that in a project which I reviewed, that developers thought that wrapping a function with a callback is going to make the child memoized. And that wasn't the case because they were not using React Memo, for example. So the callback didn't make any sense here. It was only an additional cost without any benefits. We've mentioned React.memo. So let's think for a moment when it's a good idea to use it. The first condition which should be met is that the component which we want to memoize should be pure in terms of properties, state, and context. So every time its properties, state, or context change, the rendering should return the same result. When it's not going to happen, for example, if the component uses current time, then it's not going to be pure because there's some external source of data. Also, the component should be rendered often enough for the memoization to be profitable. Because if we rendered it really rarely, then it doesn't make a lot of sense to memoize it. And memoizing and rendering it should be really heavy, because if the cost of rendering is really small, then it might be just cheaper to render it every time. And finally, we have to make sure that the properties aren't changing too often, because if with every render the properties will be different, then yeah, our memoized result wouldn't be used. And now let's talk about use state. So the next mistake I will talk about is using inappropriate setState function. What does it mean? There are two functions which can be used when setting state. One accepts a value and one accepts a function. Yep. One with a value and one with a function. And why it's important to use, or maybe when to use one and when to use another. For example, when we're using, when we're setting a state multiple times during one render period, then if we were using only the first one, then the value set in the state will be incorrect, because React didn't have a time to update the value before every setState call. And the solution is to use a function which takes previous state and returns a new state. And when we do that, we can safely write this code and it's going to work. The result will be that the value is increased by 2. But using the approach from the previous slide may introduce a new issue. If we would like to store a function as a state, define it, and then call setState with its value, the result might surprise us, because what React is going to do here is to invoke this function and assign its result to a state. To avoid this issue, we can, for example, call the variant of setState which accepts a function, and then ignore the previous state and assign our new function to a state. Another option is to replace a function in the state with an object which one property is this function, and then we can do what we usually do. So set the state as a set the object as a state. So yeah, when we want to store a state of the component, we usually want to use state, so the hook use state, but sometimes there's a better alternative. So this code doesn't have any obvious problems, but it can be improved in a way. What happens here is that every time user clicks increase button, the state will be increased, but also a new render will be triggered. To avoid that, we can replace state with a ref. I will highlight the differences between those two codes. And here we can see how easy it is to replace this code. And the second one is a lot more efficient, because the render will happen only once. We've learned that useRef can be used instead of useState, but what if we want to depend on this value? It's easy to depend on state. It's harder to depend on ref. We can list .current property of ref into dependency array, but we should be careful while doing that. Something which was a benefit in the previous slide might be a trap here, because the effect, we need a way to trigger a render, and changing the ref doesn't trigger a new render. So if we don't care about it, that's okay, but if we want a render to happen, we should make sure that there is another reason for this render to be performed. And in this last part, I'm going to mention a use effect hook. So there are a couple of scenarios in which we need to clean after our effects. What do I mean by cleaning? Well, usually it's about removing listeners, timeouts, intervals, and it's easy to forget about it, but the consequences might be serious. For example, our application might crash, the memory might leak, or in the best scenario, we're going to receive a warning from React. And cleaning by using effect is easy. It's about returning a function which is going to be called when the dependencies change. So the flow is that the effect will be called, then when dependencies change, the function we returned will be called, and then another effect will be performed. And we can also use this code as a replacement for a familiar component will unmount, which is the effect with only a return statement. So to sum it up, using SNIT plugin is a huge help. It let us avoid a lot of issues and make informed decision when we would like to violate the rules, because we don't have, for example, to list all the dependencies. When using dependency arrays, it's important to memorize objects or arrays functions which we pass to it, because if we don't do that, then the dependency will be different every time a render happens. When you're memorizing your objects, do it wisely, because it's not always a good idea. The cost might be significant, and yeah, it's always about trade-offs. When using state, spend some time considering if refs aren't good enough for the job. We can then save a lot of processing power by not triggering renders which are not needed. And finally, clean after your effects. It's easy to forget about it, but the consequences might be severe. Yeah, so thanks for your time. I hope you find this presentation useful and you learned something new. If not, then it's also okay, because it means that you mastered effects, and I'm also happy with that. So thanks.
Hi everyone, my name is Alek, and yeah, I hope I will be talking until the pizza comes. So you won't need to drink beer and not have anything to eat that with. So cool. First off, I wanted to talk to you about implementing design systems. I know the topic was cross-platform, and then I saw some posts that it's something about cross-platform, so without even the design systems part. But I'd like to mostly focus on, first of what even that is, and then give you some tips on maybe some best practices during implementation, maybe some business issues regarding that, and just general concepts. Does that work? Okay, yeah, it works now. Cool. So what even is a design system? So I'm sure you must have heard the term design system because it's thrown all over the internet and all over like the front end side of software development and design in general. And it's often confused with the other term, which is like a component library. So when we, as developers, we think of design systems, we think of this folder that lives somewhere in our project that contains like a set of files that's like a button and an input field or whatever. And we say, oh, we have a design system, but everything still looks random and it doesn't really fit one another, and something's wrong. Design systems don't work. And that's not really the case. We're just, first off, using the wrong name, and we're not thinking of it holistically, and we're not really putting the correct attention. So when you work with a designer, when you actually put some effort into creating like a consistent style and consistent brand feel, we can call that a design system. So it's like a collection of shapes, of typography approaches, of colors, of even components. But it's like this large collection of everything that is associated with our brand or with our design system. Anything that allows a person to identify, yeah, that's the company I know, that's the app I love using, is a part of a design system. But a component library, on the other hand, is just a very small subset of it. So it's just a folder or a set of components that developers can use throughout the project to achieve a consistent look and feel easily and quickly. So it's just import a button, and then you have a button that's perfectly styled and looks like all the other buttons in your app and screams, yeah, this is like the app that I'm using, or this is the app that I'm developing. It contains also basic components, but then it can grow into very complicated montages or just compositions. So here's a very good example, which is the one that you've all seen so many times that you basically hate it right now, which at least that's my experience. Every app in material design looks the same. Yes, it does, because we're all using this part of material design, which is like this base implementation, base design that's just a general idea. But good apps that use material design use something that's in the middle. So they customize it, they enhance it with their own colors, with their own typography, and border radii, anything that basically changes the material design and makes it less boring and more custom. So those are two examples of a design system on the left. And on the right, you have an implementation, so a component library. It's basically Material UI, which is like the most popular library for React, I think, at least in terms of component libraries. And it's a set of components that have variants, that have styles and can be customized, but are just an implementation. So you can just import them to the project, drop them in, and start using them. So yeah, we have those ready-made component libraries, as you just saw, and you can obviously use it. And there are loads of different ones. Undesign, Material UI are like popular, but there's many up-and-coming, Grommet, Bootstrap. I personally recommend UI Kitten, especially because we're on a React Native meetup, and this is the one, and I think one of the only ones that I found that works really well with React Native and React Native for web. Since for some reason in terms of dead space is very limited. And there are loads of component libraries. I'm probably gonna mix those terms, sorry. Still. There are loads of ones that work for React, but for React Native and something that works on the web, that's quite a limited space. And I've also got some tips for what you can look for to achieve success and not have to change the component library midway through, and what helps you speed up the development work. And this is to find something that provides design kits for design software like Figma. Even if you're not having a designer right now, at some point in the project, it might turn out that you want to hire a designer. And at that point, if you don't have it, you need to redraw everything and implement everything, not only in your software, in your React app, but also draw everything in Figma or in Sketch or Adobe XD, whatever. It's just that there are some design systems or component libraries in general that provide ready-to-use visual and design files. The other just as important thing is to look for something that's obviously stable, very popular. So if you have any issues, there are people that can resolve it and can make a PR for you instead of you having to go in and fix that. But also that's customizable and that has a very high quality API. And yeah, I know a high quality API is just like, what does that even mean? But I'll explain in a second. Or yeah, actually towards the end of this talk, because that's kind of the main point here. And the last thing that you can kind of initially start thinking on is whether you want to go with something that's headless or opinionated. So headless, besides being a name for a rather popular design system, that's a component library. See, that's a name, but it's just the idea that those components don't really have styles attached to them. There's just a set of base behavior and logic that you can use to build upon that base behavior. But then you provide the styles, you provide the colors, everything. Or you can go with something that's opinionated. I personally think that material design is somewhere in between. And component libraries like Grommet are on the more opinionated side of the scale. So that's something that enforces some sort of look and feel. And you'll have a hard time adjusting all the components to match it. They're just not thought of being able to be adjusted like that. So that's cool. We can use something that was ready-made. Let's just import that, npm install, and let's use it. But what if you want to make your own? And why should you want to make your own? Or maybe you shouldn't. First off, some words of caution. That's a really big project. I know because I am currently working on an app that has a custom design system and a component library that has been created in working together with a very good designer. And now we've onboarded a second designer into that project. So it has gone all the way of kind of agile design from Figma to implementation and back. And we've been trying to kind of achieve best practices. But it turned out to be a very complex project in of itself. So it's not like, it seems easy because when you take a button from React Native, you style it and you think, oh, I created a button, now I can create all the rest. But then it turns out that spirals out of control quickly, and components are becoming more complex as you need them, and they're always quite cheaper to create in designs than in implementation. So you need to be aware of priorities, and if you start implementing everything and just letting people kind of ask for things, I want a calendar picker that allows you to select date ranges, then you end up just importing random components from npm because you can't implement them yourselves, and it starts looking quite bad. But I'm not saying that's a bad idea. You can also supplement your custom component library with some imported components and just style them for some parts that are less important to you but are needed for the project. And I've actually found some good resources on the organizational project management side of things. So here's a link that you will be able to kind of look into after when you share the slides. But just that it requires good project management, priority management, and all that. But if you decide to do your custom design system, then first off, it's really interesting. That's one of the nicest kinds of projects you can work on, I believe. That's my opinion. That actually implementing a design system from scratch and a component library to go with that is a really satisfying thing. And second of all, you can change everything and you can customize it, and you can I think that's the best way to actually give a custom look and feel to your app. You can take material design and style it, but then everybody knows it's material design, but you change some colors. But if you create a custom design system and a component library, like Uber, then it's instantly like a sign of a very good app and very polished, very kind of influential app. Now everybody just talks about like Uber design system and Uber components. That's like this ubiquitous style with the black buttons, for example. So that's what I mainly wanted to talk about, which is if you decide to go with the implementation, what are some of the good best practices you can put into creating the API for the component library, and just in general, how can you implement the component library? Yeah, I'm calling them laws, but they're just suggestions because I came up with them this week. So yeah, it's not like it's written in stone. It's just my opinion based on some experience that I've had and some failures that I've had also. Work, goddamn. Yeah, it goes. So first off, not my idea. Again, there's a really good book and just a concept by Brad Frost that's called Atomic Design that most of you or part of you might have heard of. And it's this idea that components or items in your component library are not just a flat list, but are actually structured into a hierarchy, a tree. And you start from the most basic components, which is like a text or a button or an icon, and you use it throughout your other components that are on the next level. And you call those components, the basic ones, atoms. And you then take those atoms, you combine them together, and you create also quite basic components that already serve a purpose. Like a text field or a button is a molecule, in my opinion, because that's also very subjective. And then you take those molecules and you combine them into organism. Yeah, there's a very clear metaphor for atoms and molecules. The name isn't quite random. So what's the benefit of this over just having a text component and some styles? The main one is that if you want to go with the true design system approach, everything that you do in one place of the design system should be reflected throughout the rest. You want to go for maximum consistency. So in effect, if you duplicate code or you duplicate styles or you duplicate any piece of logic, you don't have to go in and change that twice, which is already like a big loss, and that will spiral out with control. You'll have very divergent, weird looking and non-consistent component library. So this is one way to, yeah, no spelling errors. This is one way to get that fairly easily. But it does require to create more files, and then you go around creating files like text, which is like your custom text that just imports React Native text at the beginning, and you feel kind of crazy because that's just generating random files, but it's not, and this actually makes sense. And I like to call it that if you see something in an organism that you like a piece of some structure, something that looks nice, and you want to reuse it, or your designer wants to reuse it, then there should be an already made atom for that, or an already made molecule. So you should be able to just go in and copy that instead of, what was that margin? It was 10 pixels. Yeah, okay, now it looks nice. That's not good. The second one I've got is to provide sensible defaults, but allowed to change as needed. And until a few days ago, this slide basically said, but allowed to change everything. And then I showed that to a colleague, and he said, that's not really the case, and you're quite stupid, and this isn't right. So I had to go in and change this. Because I personally, when I use something like an NPM library or something that's not really done by me, I want to be able to go in and change everything. So I don't like this part of a component. I can just provide a render prop function that replaces it. Or I can provide some style that completely changes it. But then you sacrifice consistency. So it's quite a trade-off. You need to think on, when creating your component library, you need to think on what you should be allowed to change and what you can't change, because it would break the design system. So here's a good example. We have 3 implementations of the same button, and the first one is the most restrictive. So only thing you can do is you can create a send button, whatever that means, or you can create some other variant of a button, but there's not really any customization there. The second one is a bit less restrictive, where you can change the icon in any way you want, but it's a string, so that's like a set of closed icons. So you can just provide some random SVG there, or you can just drop in any component. You can just drop in one of the icons that is approved by the design system, by the component library. And the third one is the least restrictive, the most customizable. So what you can do is you can provide a left attachment that's either an icon name, or it's a function that renders a JSX element. So if you'd like a checkbox there, you can just drop in like a function that renders a checkbox. And this is the best way for me, but notice that you still provide sensible defaults. So if you don't provide it, you just get a plain text button. If you provide the left attachment, you can provide there a string, and then it will render like a send icon. If you provide send in the left attachment slot on the props, then it will render a send button without you having to go in and import like an icon component and passing that to a render prop. Because if you want something that's fairly simple and following the component library, then it should be easy. If you want something more advanced, more complex, then you should go in and kind of tweak those settings a bit. But you should be able to. You shouldn't have to do like a patch package on a component library just to be able to show a different color and icon. And one more pattern that I'd like to highlight here is that the render prop function passes a button state type, which highlights the current state of the button. So if you want an icon that changes color depending if the button is focused or not, you can fairly easily do it here. Yeah, and this is, again, you can pose some questions when creating a component library API on what you'd like to be able, the user or the end user, to do. If you want to put a checkbox in a button, maybe that's okay. But if you'd like a small chart, like a spark line that you see nowadays fairly commonly on a button, maybe that just isn't kind of allowed because it breaks the design system. There's no like styles that include that, and it will just look awful. So we'd rather the user be prohibited from that. Which makes sense, because when you have a large company, you usually have separate teams that are working on the design system and the component library to go with that, and separate feature teams. So you'd like those feature teams to not break the design system, to not just go in and do stuff because it's easy for them, to follow what was set for them by the other team. And there's a really good talk that I was kind of shared with by the colleague that I was talking about, about building and rebuilding the Airbnb design system, which is available on YouTube, obviously, as everything nowadays. So you can go in and have a look for that concept of restrictive versus customizable. I personally prefer customizable, but I can see why this is not like a clear cut. Yeah, just let the user change everything kind of thing. Cool, so we're on to paragraph 3, which is that you should unify, expose, and document not only components, but also logic and behavior. So what's that about? You can obviously like create a folder that contains a list of components, and that's pretty fine. But if you want to make something custom, you shouldn't have to, that's not included in your design system yet, but you still are confident that you can recreate the design system in a separate component, not imported from the component library. You should be able to still grab as many things as possible that were already created from the component library itself. So for example, you could say that you export a button as a button that's you can just import or not. But what if you expose also some behaviors from the button? Like, for instance, we can have the ripple effects. They're ubiquitous with material design, but you could export them as a separate component or a separate kind of button-based file, and then you can reuse them on any custom component that you'd like a selector here that's for like plants, different plants that still have the ripple, because we are able to base them off the button base. If the button base component had already some look and feel or something that didn't suit that, for example, it had like the blue background, then we would have to recreate that component basically from scratch, and we would have lost that ripple effect. As long as you can provide consistency on a custom component, it's better to import the button base and to have that ripple for free, essentially. And you can also abstract stuff not only as components, but also as hooks. They're a really nice way. Yeah, following the last talk, you should all be aware kind of what are the pitfalls there. So you can also reuse hooks as kind of composable pieces of logic, stateful logic. So for instance, I came up with an idea for a hook that's called use smart loading, which is kind of following that good user experience pattern that if you click a button and the action that happens is instant, then there's no point quickly switching to loading UI then to switch back to a new screen, for instance, because that just confuses the user. But if the action would take some time, like 4 seconds, then it makes sense to switch to the loading state of the button. So the user knows that something is happening. So we can separate that as a piece of logic that says if you're loading something for less than 100 milliseconds, then you still keep the old state of the button. But after 100 milliseconds, you show the spinner, you show the loading state on the button. And you could reuse that for anything that requires loading, like page transition components or anything like that. The fourth thing is that context influences the component. Yeah, I didn't grab a beer, so now I'm getting like a dry throat. So context influences the component. For instance, here we have a button group. That code is basically like copied from material UI. So we have a button group that contains a set of a few buttons. And you can see that this isn't something that we could achieve with like a border on an outside container and some border radii. Instead, you actually have to stylize each of those buttons separately. So you have to pass some props that indicate if one of them is like a left outmost or the right outmost button. And this means that the component that renders will render differently depending on where in the list it is positioned. And that's not only the only use case. This also works for everything like dark themes, which basically use a context provider to allow you to have some parts of the app that use a dark theme and some parts that don't, or allow you to use some stateful hook to establish the dark theme depending on the time of day. So when a user, for example, changes the setting, then everything in the app changes. But this is because we are changing the context in which those components render. You can use automatic header levels, which is a really cool pattern that I didn't really see much use of in production. But in theory, you could have something like a document structure. You have a one component for a header, and then depending on how deep the header is nested, it renders differently. So you have like those H1, H2, H3 kind of components, kind of headers, but you don't have to specify that manually. So if you take a chunk of text outside of some nesting level, those automatically transition on an upper level of a heading. That's a really nice pattern. And backgrounds, UI Kitten, for example, uses those grayer and grayer backgrounds the lower you go into a hierarchy of views. And this is something that's achieved basically by context. But this pattern actually is done with something different. It's done using React Children Map and React Clone Element, which is quite a technical approach that I didn't really see a point of putting like the code in the presentation. So you again have a link to a snag. But this allows you to do this pattern where those components don't have to receive those props manually. The button group component provides them for them, even though it's not like a render function. Which is very dangerous, because if we drop something other than a button here, that would probably break in unexpected ways. So we'd probably want like either a linter rule or some sort of runtime warning that, hey, you passed a text component into a button group. So I'm pretty sure Material UI, but by that point, does something similar. So it checks if the component is a button before setting those additional props. And it's probably also not that performance optimized, because it uses clone elements. So yeah, it does everything twice, I imagine. But again, just an idea. Phew, the fifth one. So as long as context influences the component, but the component doesn't really influence its surroundings. Again, as in React, the good data flow or structure flow in a component library also goes only down. And this is actually always, there are always exceptions, but you have a primary button that's, the box is kind of obvious, because, you know, it's a box, right? And that makes sense. But what if you change that variant of that primary button to like a ghost button? So it's just text. But then should you keep the margins of the button? So when you use it throughout the app and you change the variant, the layout wouldn't change? Or should you trim that border to only contain the button itself? So I personally am fully for the second approach, because I believe that the components shouldn't influence its margins, shouldn't influence its surroundings. And that's even to a point where I believe using a margin in CSS is quite evil, because the layout of the component or the position, the size of the component should usually be depending on the parent rather than the component itself. The parent positions the component, and the component should be able to align to where it's needed to go. This is an example that's a very typical one, although quite less obvious. The button send, if we keep the original margin, would land totally in a weird spot in the form. But if you trim the margin, then it lands, it's quite small to hit, which is another problem, but it's, again, looks well and is aligned with the edges of the input, text input. So what can you do? Because, okay, now the user has a problem. He needs to tap that little spot. So you can handle that by defining hit rectangles in React Native. Which is again a very difficult issue, because those are also quite limited, and you can for example extend the hit rectangle outside of the parent container. So there are certainly, if you're looking for an open source library to develop, this is a really good idea to do something that works really nice for hit rectangles. And just maybe some way of, for example, if a user taps the screen and he's near a button, maybe you can use some, I don't know, just throwing ideas, but maybe machine learning to predict which button that should be, or just something that's a bit smarter than the current implementation. In any case, this shouldn't be the only touch zone. This is too small to hit. So this also has some benefits, but it looks bad, so automatically it's thrown out. I don't like things that look bad. Yeah, and this is also a really good kind of opinion piece on why you should keep the responsibility of the parent. Why the layouting should be the responsibility of the parent. I've read it, and it influenced my mind to kind of start thinking about this concept. Cool. Okay, I've got another one, which is that the component library API influences the user experience of the project in ways that are not immediately obvious throughout the lifetime. So you as a designer or you're still a designer, but you design the API of a component library, actually have a very big responsibility and a very big influence on the final user experience of the product that even somebody other than you might create. And throughout the definition of the API and making some things harder and some things simpler, you can influence the final products of the final outcome of products that use your component library. Here's a very good example. You could, for instance, just do a basic Boolean as a disabled button, which all makes sense. It's a very popular pattern, but then people might be overzealous to use those disabled states where they don't make sense. For instance, in form fields, the send button, if you open a form field, you probably would figure out that you need to provide your feedback, but it doesn't make sense. You click the button and it's disabled. It's not immediately clear. So this is a very bad user experience pattern. What you should do, ultimately, the best approach would be something that's on the right. So if the user clicks on the send button, you error out your feedback field. You tell them you need to provide this field, but you keep the button clickable, just so the user can kind of highlight their errors. This is even more obvious when there are several fields, some are required, some are not. But throughout those 3 different APIs, you manipulated the final person that's implementing your components into providing 3 different error displays for the state where the user tries to submit a form without providing their feedback. The first one is the worst one. The second one doesn't really make sense, but you still managed to kind of enforce that you shouldn't disable buttons without purpose, because you can't provide a Boolean true. You need to provide some reason for why the button is disabled. And the third one, you can set an easy string on the form field to highlight an error. So that might make the person implementing your component library and the person actually doing the project to set that error instead of just graying out the button. So this is like a 1 sentence sum up, that good user experience should be easy to implement, but bad user experience should be hard or impossible to implement. Cool, and now we're getting to the less kind of opinionated and it's just my idea part of the presentation, and I've got a few more tips on what you can do to improve the quality of your API. And this is like the most basic one, which is to use TypeScript. So there are some benefits and there's one major drawback, as usual in life. It prevents you from making hard to notice errors. You wouldn't imagine the amount of times I've had received a TypeScript error, I fixed that, and I was like, this would have taken me an hour to find if I didn't have TypeScript on. And it's essentially prevalent if you're using something that's not done by you. It's like a third-party API. This fairly well replaces any documentation, any kind of like, you don't really have to go for a button page and see how you can use that component. You can just enable IntelliSense, like a control space or command space, and you get all those suggestions out of the box. And it also, you can also use TypeScript as a guard that enforces only things that are consistent with your design system. It's not only for programming errors and implementation mistakes, it's also for things that should not be allowed. Or you can, for example, create some component that only works as a left attachment, that's like an icon or a checkbox, and you disallow passing a normal checkbox into the left attachment of a button. This way you can prevent the user that might not be fully familiar with how to use your component library from making those mistakes by restricting what can be put where. It's like it's basically a guard in a sense. Yeah, and the instant documentation part. But the drawback is that it can be incredibly slow on larger projects. I've talked with someone that described that there was an effort to consider writing TypeScript in compiler into Rust without much success. I know there's like one person that's working on it. So yeah, not sure how that will go, but for now it can really bog down your compiler when working on a larger code base. But from experience, it's definitely worth it. The 8th point is that I highly recommend using Storybook or any other solution like that, which is like this method to develop your components and explore your components in isolation. So you can create those stories of your components. For instance, here's like a story of a badge, and you can immediately see and toggle states and play with the components, test out all edge cases. For instance, I found out that my input didn't really accept long field names. It really looked ugly, and I wouldn't have probably found that out if I didn't have like a nice playground to just put in some text and see how that responds to the prop change. So this is a really nice piece of software. The only issue is that setting it up in a React Native project is really easy to do if you want to test those on device. But what I wanted to do is I wanted to have an external website that I can share to a non-technical person, like a client, to show the components to them. And I wanted to use React Native for web for that. And that was like a hell of just configs, compile errors, and just building it was a pain. But once it works really nicely. So that maybe sounds like a good article. Cool. Coming to an end, there are like 2 more. So I want to kind of highlight how those component libraries bloat over time, especially if you're the same team that's working on a design system component library. Yeah, I really should say component library that time. If you're working on a component library and you're also working on the product in parallel, there are like these moments where it's way easier to add something as a prop to the component imported from component library than to think of doing a proper way, which would be to do some composition, break stuff into more atoms, or just figure out a better way. And then when you look at the API after some time, you see that it contains like these weird things that you're not really sure what they do because they're used in like one place. So that instantly screams like fragmentation, bloat, just difficulty to maintain, etc. So this is like an example that I've shortened. I've removed like half of the props from a project that I'm currently working on. And I think that the props in red are essentially useless here and they should be handled otherwise. But it's only really easy to see after some time. And now refactoring that would be a pain, so we're probably gonna keep them. But if we had a better discussion early on in the project, if we didn't pass review because it would have been like the component library is quite a restricted piece of the system, then it might have been better. But on the other hand, this is again from the Airbnb talk, if you do it too much, if you pose too much restrictions and you make it into a philosophical debate or whether that fits into your component library, whether that makes sense, then you're basically making your engineers just implement those components by themselves. That also applies to project directory, and that also applies to the button logic, which is like this large tree of ternary statements and ifs. Last two ones, think about versioning. So you have two approaches. You can either version your component separately, so you can do like a semantic versioning. That's my component library is at version 1.0.3, and you can upgrade to 1.0.4 if you decide to do so. This is beneficial because if you change something that it doesn't change immediately in people's projects that they are working on or in your project, but in places that you don't want it to change. But on the other hand, if you just do it like a YOLO style and you have a folder that contains all your components, then you don't really think about versioning, you don't have to do releases, and you just change stuff and it works. I think as long as you do good quality control and good API that works, that you can drop versioning component libraries. I know that some component libraries like Material UI obviously have to do that because they're used by multiple people. If you're doing that in-house, you don't really have to. Airbnb has a very interesting approach that I also encourage you to check out later. And the last thing, which is basically a nod for GraphQL, because I always talk about this, so I didn't want to skip that, is that you can use GraphQL for your components, which obviously breaks encapsulation and separation of concerns and all that, but in React, you already have some stateful logic in stuff that renders out your components, so might as well go in all the way, and you might describe what data is needed on the backend to render a component, like an organism. And then it's very easy to just provide the data for the component, which is a really nice pattern. And yeah, that's about it, so thank you for listening.